Tricky question this, so I'm going to do spoilers to show you how it's done. So 2 moles of an ideal gas. So I've got, what have I got? I've got pressure times volume equals nRT. So increase in pressure. Which one's going to increase pressure? Well, I'm going to eliminate things that aren't going to change because I don't have to work out the exact value of pressure. I just need to work out when things are changed, how much the pressure's gone up by as a factor. So is it doubled, tripled, quadrupled, whatever. So I just need to work out how much it's gone up by, and I can eliminate from some of these calculations the things that aren't going to change. So I can work out how much it's gone up by rather than its precise amount. So volume isn't going to change. V is not going to change. It's a fixed volume. N, the number of moles, is 2. So that's not changing. R is the gas constant. That's not changing. So V, N and R are not changing. So P equals, V isn't changing, R isn't changing, N is 2. So P equals N times 2. And the V and the R are just constants in there. So I'm going to leave those out for the time being because it won't really matter. Those are just numbers that I'm going to include in every calculation. So when I'm working out how much it's gone up by, those are relevant. So let's have a look for A, increasing the temperature from 20 to 200. So my pressure is 2 times 293 is 20 degrees C, 273 add 20, so turn it into Kelvin. Remember, temperature's got to be in Kelvin in this equation. 2 times 293 is 586, and the new pressure is pressure 2 moles 2 multiplied by 473, because 200 is 273, add 200 is 473, 946, so it's gone up from 586 to 946. It's nearly doubled. The way that I'd work out how much it's going up by, it's going up by a factor of 946 divided by 586. If I divide the bigger by the smaller, I work out how much it's gone up by. It's gone up by, it's multiplied up by a factor of 1.61 times bigger. Let's have a look at B then. Adding another mole of gas to the flask. So pressure equals 2 moles times temperature has gone up to 3 moles times temperature because the number of moles has gone up by from 2 to 3. So it's gone up by a factor of 2 up to 3. So it goes up by a factor of 3 divided by 2. It's gone up by 1.5 times. 1.5 2t comes out as 3t. So it's gone up by 1.5 times. C, adding half a mole of argon gas. So the number of moles in the first instance is 2, and then it's gone up to 2.5 because I've added half a mole of gas when I've made the change, and increasing the temperature from 20 degrees C, which is 293, so 2 times 293 is 586, up to 150, so 273 add 150 is 423, multiplied by 2.5 because I've got 2 moles of gas and another half, 2.5, it's gone up to 1057.5. So this one has gone up from a pressure of 586 to 1057.5. It's gone up by a factor of 1057.5 divided by 586. It's gone up 1.8 times. And then finally D, removing half a mole of gas, so it's gone from 2 moles down to 1.5 moles here now. From 20 degrees C, that's 273, add 20, that should be 293 there instead of 283. 2 multiplied by 293 is 566. 1.5 multiplied by 573, so that's 273, add 300 is 573, gone up to 859.5. So it's gone up by a factor of 1.5 times. 859.5 divided by 566, 1.5 times. So which one has gone up the greatest number of times? 1.61, 1.5, 1.8 and 1.5. The answer is C, because it's gone up 1.8 times from its original amount. A tricky question.